Hey, what's up everyone, and welcome back to another episode of Naked CTF. In this series, I'll attempt to compromise and own a server from HackTheBox. This is my first attempt. I've not solved it beforehand nor read anything about it. It's one take with no editing, so this could be 30 minutes or 3 hours. Let's go. Today we are doing Builder, which is a medium box. Thought we might try a medium, see how we go. Jeff spawned it, so let's get started with our recon, as always. Fire this thing up. And off we go. While that does its thing, boys got a couple of minutes to wait for that to complete. Yeah, getting back into the swing of thing. I've been doing a few seasonal boxes, which has been cool. Where is it? Season 6. Had a lot of fun with that. Unfortunately can't record that, obviously. Popped Cicada yesterday. That was actually quite tricky. The path was a lot of twists and turns to get to route, but it was quite fun. And I wish I just had the time to do each one of these boxes while they were actually active. I've only been able to do one easy, one medium, so was able to fully route that, and one other medium where I only got the user flag, I didn't get the system flag. So I'm going to try and keep on track. The next one is a hard box. So yeah, we'll see how we go. If we get the user flag, I'd be happy. But yeah, that's what it is. So seasonal, really enjoy it. It's incredible. Actually, this season 6, this box, Cicada. I don't know if we can see it right now, but it was quite controversial in the Discord. Yeah, so this guy NTLE, who's kind of top of the leaderboard at the moment on HackTheBox for this season, and just in general, I think he's doing really well. He's obviously just superhuman. Yeah, he's completed 72.5% of HackTheBox guru rank. Team is ranking number 1 currently, Thug Shakers. But he got the user flag in 3 minutes and 13 seconds. And then it only took him like another 25 seconds to get the system flag. So he completed this easy box like in under 4 minutes. So that is crazy. I think I spent about 3 hours trying to do it. So it's not about the time, I know, but it was absolutely bonkers like how quickly this guy got through it. So all right, enough of seasonal. Let's go back to what we're focused on, which is Builder. Let's take a look. We've got port 22 SSH. No big surprise there. This is a Linux box, so we'll just capture that for now. And then we've got port 8080, which is running HTTP. And we're going to grab all of that and just have a quick read through this. So that's it. 2 ports, pretty straightforward as always. We'll kind of leave TCP alone. We'll leave SSH alone because it's pretty unusual that the foothold is gained via SSH. Usually you need to develop some credentials, so we'll put our focus onto port 8080. So we can see here it's a HTTP server. It's Jetty HTTP. Jetty is usually the HTTP server built into some of the Java frameworks like Spring, I believe. Let's just quickly check that. Jetty web server. Or as a standalone component. Java servlet container. Used in products like MQ, Google App Engine. Yeah, so it's like a standalone component, and then it gets embedded into other things. So what we can tell straight away is that the server header is telling us Jenkins from the HTML title, which is interesting. So let's grab the IP. Let's go here. Let's go 8080. And there we are. we have a Jenkins dashboard. So for those not familiar with Jenkins, it's a CI/CD tool. It's usually used, it's primarily used for orchestration, but it's a bit of a Swiss Army knife in the sense that it can do a lot of things. It can do scheduled work. It can do pipeline work where you have one stage of the pipeline trigger the next. But yeah, generally people use it to coordinate and orchestrate their DevOps processes. So, right, straight away we can see Jenkins 2441. So let's make a note of that. So 8080 TCP HTTP is going to be Jenkins 2441. So we might look at CVE for Jenkins and or Jetty. But let's just have a click around first. So Jenkins, when you're unauthenticated, still you can interact with it. It's not like it has a login page up front, like there's this kind of anonymous user. But if you want to do anything serious, you need to authenticate. So let's go back to here, and we've got Jennifer. User ID Jennifer. Okay, so let's capture that. And we'll grab the URL as well. So that's the people, build history. Oh, people. Yeah, so I think it's just created that anonymous ID now that I've kind of hit the web server for the first time. Because there was no profile for me as a non-authenticated user. So I've kind of seen that behavior before. I have used Jenkins in the past, like in a real world job type scenario. So some of this is familiar to me, but it has been a while. So let's have a look. Build history, nothing there. We can't see any project that's building. Credentials, we do have this system store, global credentials that should be available irrespective of domain specification. And then we have this ID1, which is root SSH username with private key. This credential is not being recorded as used anywhere. Okay. Might just take a note of that. Credentials, store scope to Jenkins. I feel like this might be OAuth, maybe. Yeah, we can't add a domain. Maybe these are used for OAuth, so that you can use like GitHub or Google or whatever identity provider that you want to authenticate to Jenkins. Okay, so nothing particularly exciting there. Build executor status. It's got one node which is running on itself, so it's self-contained. Doesn't do distributed builds. Idle. This looks like quite a recent looks like quite a recent build of Jenkins, because it's definitely got an improved UI from what I remember. Now, we have done a Jenkins exploit in a previous box, because I do remember at some point. So, unbelievably, if I could find... Yeah, look at that. I've even got some notes. Pen testing. Let's grab some of this. Pen testing Jenkins. Alright, get rid of that. Yeah, the Jenkins has obviously got a API for all these elements because it does need to be heavily integrated with. because it is an automation and orchestration tool. Okay. Good old hack tricks. Unauthenticated enumeration. Search for interesting Jenkins pages without authentication, like /people. I think we've done that. Async people. Yeah, we've seen that. Without credentials, you can look inside security realm. Yeah, I think we've got all the... usernames there is. I think there's just that one Jennifer. Let's just try some of these paths. So you will know I am trying to be a little bit more enumeration conscious rather than just jumping straight into looking for a CV or something. So one thing that the seasonal boxes have taught me is that enumeration. So you can get the version by using /oops/error. We've actually already got the version. It's on every page, it seems. So that's good. Non-vulnerabilities, pwn Jenkins, notes about attacking Jenkins servers. Create an account and log in inside it, as simple as that. We can't do that. We can only log in. There's no option to create. There's no SSO because it doesn't look like this is integrated with GitHub, Bitbucket, etc. Jenkins lacks password policy and username brute force mitigation. So you can do brute force or password spraying. Okay. SaaS-based SCM such as GitHub or GitLab. Yeah, well, this is kind of the setup that we had. CI systems to receive webhook events from SaaS source control. Yeah, so we had, in a previous life, I had the source code management done in GitLab, hosted GitLab, and then all the hooks would call back to our self-hosted Jenkins instance to fire off our various pipelines. And what it's saying is that all you need to do is figure out what that webhook address is, or what that webhook URL is, go and register an account on GitLab, and you can also fire that webhook because you're able to bypass the IP whitelisting. That's a good point. Suppose you have a valid account to access Jenkins. Not yet. We've already done that. Dumping builds to find clear text access. No builds available. Stealing SSH. Compromised user has enough privileges to create, modify a new Jenkins node. SSH credentials already stored. Yeah, we don't have those credentials. RCE. Getting a shell in Jenkins server gives the attacker the opportunity to leak all the secrets and environment variables and to exploit other machines. Yeah, that's a good point, because the actual source code and various artifacts that Jenkins is dealing with and managing, like your production application, it's doing the build and running testing and running deploys and everything else. Potentially there's a gold mine of information there, various keys, secrets, all that sort of stuff, which then allows you to move laterally into other parts of the environment. And that's not cool. Like, really, you should be using a hosted secrets manager. There should never be any credentials in your source code. So, but we all know that's best practice, and reality does not always reflect best practice. Creating, modifying a project is a way to obtain RCE over the server. We're going to assume you need credentials for that. Modifying a pipeline exploitation again. This is all authenticated stuff. And yeah. Pipeline RCE. Checking environment variables, dumping secrets. Credentials can be scoped to global providers or specific projects. Okay. Okay, so that's the scoping that we saw under here. So I guess a user gets tagged to a scope. Oh, okay. No triggers, no nodes and agents, just the default node, which is the same node that is hosted on the Jenkins instance itself. Arbitrary file read to RC via remember me. Post exploitation. There's a Metasploit module to gather all the secrets. These are the files needed to decrypt Jenkins secrets. Secrets, master key, hands-on.util.secret. Usually found in credentials.xml, jobs, build, jobs, config. Here's a regex to find them. Decrypt them offline. Use this script to decrypt those secrets. Cool. Now, keeps referencing Groovy. From what I remember, there is within Jenkins itself like a DSL domain specific language that's implemented in Groovy. So it's kind of like a scripting language that you can use within Jenkins to write code to automate stuff. And from what I remember, there's also a console in the browser where you can run Groovy code. I think that's how we did it last time. That was the exploit, was that the console was exposed. Add a new admin user. Okay. All right. Well, that's been very useful. I think we've done a good amount of enum on Jenkins. There's no real obvious stuff. It seems super vanilla in the sense that they've added this Jennifer user. There's no build. There's no pipeline. There's no... Everything else looks, you know, default, right? So... Now I'm going to turn my attention to 2.4.4.1. Jenkins 2.4.4.1. Lol. Jenkins is an open source, blah, blah, blah. CVE 2024-23897, arbitrary file read vulnerability. Jenkins 2.4.4.1 and earlier. Does not disable a feature of its CLI command parser that replaces an @ character followed by an file path in argument with file contents, allowing unauthenticated is good. We're unauthenticated to read arbitrary files on the Jenkins controller file system. This exploit scans whether the provided target is vulnerable to CVE blah and reads the file supplied from the remote server. For this exploit to work, one of the following conditions have to be met. Legacy mode authorization, configuration allow, anonymous read access is checked. Logged in users can do anything, sign up feature is enabled. Well, that's not, but we only need one of these three. I think this is enabled because we have the anonymous user that was created when we got here, we are able to, you know, view things like the people directory, that sort of stuff. So this looks like a winner to me. And I think we can potentially use this I think we can potentially use this to extract stuff from, I mean, the example here is Etsy password, so it seems like we can extract anything that is readable by the user Jenkins is running as. So it's read only. Right, let's give it a try. Copy. Let's make this bigger. Exploit. And Vim CVE 2024 23897 23897.py. Stick that in there. Let's have a quick read through it. It's got some cool ASCII art, always good. So does a post to CLI remoting equals false. I think that's a one of the 3 checks. Then another similar check, maybe. A little bit different payload to. Okay. It's actually sending some binary data. All right. Or maybe some UTF. Creates 2 threads, starts the threads. All right. Doesn't look like there's anything malicious on there. Always love running random untrusted code. So URL is going to be this file. Let's just do Etsy password. Some error occurred. Okay. So it's in this try block. What are we missing? All right, so let's walk through it. Build the arguments. Check the argument target URL, target file is there. Do a simple regex. Make sure it matches. Run the ASCII function, which just does that. Nothing crazy in the imports. And then exploit. Going to actually clone the repo See password. Some error occurred. Now, I don't think it's failing. It's not failing because it's not vulnerable. Because those first and second functions get called. Yeah, so they... Okay, so they're not vulnerability checks, that's the actual exploit itself. Okay. Let's see if we can find someone else who maybe has taken a different approach to this. Alright, this looks like a different implementation. Oh, and it kind of gives a like a web shell interactive terminal type thing, which is nice. Alright, let's give it a try. Okay, URL is HTTP IP 8080. See password. Yeah, okay. So this particular implementation of the exploit works. Not sure what was wrong with that first one. Don't know why it was broken, but if we look at the actual exploit here, send upload request. So it sends an @ plus the file path, which is what I typed was etc password. Yeah, it looks like it's a bit cleaner. It uses this different encoding, different way of doing encoding rather than actual hex bytes. So maybe it's just a more stable implementation of the way that the payload's constructed. And it packs some null bytes on the end. pretty cool. Interesting, interesting bug. Okay, so look, it even gave some examples here of what to poke around at. Proc self environment, which is our environment variables. So for those unfamiliar, the /proc file system is like file descriptors that represent some in-memory structures. So I encourage you to go and read up on that. I don't fully understand it, but I know that when you set an environment variable, apart from, you know, being able to read and write that environment variable through the shell using, you know, shell commands, you can also interact with it from a file system perspective. So proc is huge. You can even, if you have root permission, you can change kernel level flags and parameters and everything else that you might do using sysctl and that sort of stuff. So, right, home, var Jenkins home. So let's just grab all of this. This is all useful stuff. And let's grab the exploit that we used. So what do we want to do? Problem is we can't do directory listing. But we do know we have a user Jennifer within Jenkins, which is separate to the Linux user. So let's just try some of this. Let's just go through these. Well, these look like they're useful and of interest. So this is the command line that's used to launch Jenkins. So it's Java, and then it specifies the root, the working directory for Jenkins. Yeah, we know all that. That's all Java parameters, and then the Jenkins Java WAR file itself. Etsy host, that's a great idea. Nothing special there. It looks all default. There's no subdomains or anything like that that we can spot. So we should expect to see Jennifer in here. There she is. So let's grab that. Then let's grab, so Jennifer /config as XML. So it looks like every user has an individual configuration file. File that does not exist. Var Jenkins home users Jennifer, Jennifer, Jennifer. Maybe it's this string. Let's try this. This might be the internal reference. Okay, try again. It's better. All right. Oh, that's a lot of XML. All right, I'm gonna cheat a little bit here. Then we have a password hash down the bottom, which is awesome. Love a password hash. Starting to potentially develop some credentials. So a quick read through this. Roles. Last granted, whatever. Authenticated, whatever. Okay, Jennifer at builder.hdb. Let's capture that. Start building our credential list. Let's add that long form internal ID. Is like username concatenated with some other value. Okay. What else we got? API token? None. Seed, that might be useful. Might be part of the password hash. Let's just grab this whole tag and put it down here, and then we figure out how to deal with that. And then we've got the master key, which we were reading, which we were reading before, is okay, let's grab that. Yeah, the master hash, which we were reading about before. Needed to decrypt Jenkins secrets. Master.key. Yep, okay. And then Hudson util.secret. Okay. What was it? Hudson.util.secret. Ooh, okay. That's binary. How are we gonna get that? If you dumped the needed passwords to decrypt the secrets, use this script to decrypt those secrets. Okay. I think copying and pasting this is not going to work because it's just going to absolutely mangle this thing. Oh, see, it's even screwed up my terminal. Okay. So can we just download the file itself? URL HTTP IP 8080 F we want this path, and we want this file. Ayo. Hudson.util.secret. I don't know. Let's try. I'm feeling this may not work. I just always get a little bit sketchy when handling non-ASCII data. It always seems to go wrong for me. So let's create a directory called crack. Let's move the Hudson into crack. Let's create master.key. What format does it want? It's just a hex string. Nope. Don't want that. Okay. And then we want the actual password hash. I think we include the XML tag. Credential.xml. Vim. Credential. XML. It's good. Then what is this repo? Alright, this repo looks pretty good actually. I'm gonna add that here. Oh my god, already had it. Oh dear. This is why I need to organize my notes. I'm now at a point where I'm putting it off. Procrastinating. Vim decrypt py. Alright, Python 3 decrypt.py. Okay. Vim decrypt.py. pip3 install crypto. Should have it. Huh. Pip crypto cipher AES. Pi crypto. All right, install that. Oh, jeez. What are we missing? Oh boy. Doubt it's a permissions thing. Because it's actually compiling something. Build fails. Yeah, same issue. Okay, let's try this. Everything was going so smooth on this. Just had to be something. We should already have this, so I doubt this is going to work. Yeah. User include Python 3. User include Python. .311. C Python. What file are we looking for? Long int find minus name long int. Let's copy it. Copy C Python long int to the parent. Hey. All right. This works. Oh my God. Oh my God. What year was this? Okay, 2023, not too long ago. Upvote this dude's answer. This is exactly the fix. Man, what did we do before Stack Overflow and Google? I remember, actually. I am old enough to remember I had a stack of books. I had a bookshelf that was buckling under the weight of those books. But yeah. Man, I can't believe that. Oh boy, I'm still giggling about that. That was like the most obscure kind of answer. But there it was. Just had to copy a header file from one directory to the parent and it fixed the whole pip break. To be fair, like, back in the day, we didn't have all these frameworks and everything else. It wasn't as complicated. There was not as much opportunity for things to break. Pip and Ponder and, you know, NPM and everything else is great. But when they break, they really break. Okay. Now we got our thing. Master.key. Hudson. Credentials. Ayo. High SS size T clean macro must be defined for hash formats. Yeah, this is... It's throwing this error on the... Hudson secret. So I think given they've got master key and this Hudson util secret, like it's actually unwrapping a key. So it's a key that's encrypted. So you need to unencrypt the key in order to use the key to unencrypt the secret. Okay. Let's see. Take a bit of a stab. What's the util? Okay, so yeah, this guy's kind of discussing the same problem. Jenkins encrypts all secrets using two keys, master key and Hudson util secret, the latter being stored in binary. All exploitation scenarios listed by the team rely on the ability to read binary files. i.e. Hudson Util secret. Therefore, at most everyone, including me, drew the following conclusion. An unauthenticated attacker cannot exploit the Jenkins service, but has to rely on another service or misconfiguration on the same machine to retrieve the secrets. An authenticated attacker might not be able to retrieve sensitive, blah, 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 blah. New finding, key export restrictions. I was reminded by Alkanor that because of US export restrictions on cryptographic keys, I can't believe that's still a thing, the native JVM only supports 128-bit keys, and therefore all keys used by Jenkins in the credentials plugin that stores secrets are truncated. Jenkins decryption process, which might be easy to read in this decryption script, which is the same one that we're reading. Therefore, only the first 16-byte block of Hudson Util secret file is relevant to recover the confidentiality key. Since we're supposedly missing half the bytes of said key, the Jenkins confidentiality key can be brute forced. I'm not sure whether the advisory was disingenuous or contained a legitimate mistake, but we're not out of the woods yet, as the bar has only been slightly lowered. Confidentiality key, that is Hudson Util secret, is randomly generated, so there's no way to tell whether a decrypted confidentiality key is valid or not. There is some padding information at the end, but it's located many blocks after the first block that contains the key, so we might not be able to retrieve it. And even if we could, half the bytes leading up to that block would have to be guessed, which is infeasible. Therefore, all candidate keys have to be tried on a valid ciphertext. The plain text has a high probability of being printable, and choosing a small candidate will limit the number of decryption operations needed to reach the PKCS 7 padding at the end of it. Best ciphertext candidate is a single block long, which implies that the underlying secret is less than 15 bytes. Since UTF-8 is used to encode the file, some favorable assumptions can be made about the missing bytes. Truncated response indicates the last byte is either a line feed, OXOA, or a carriage return. Single byte is missing, blah, blah, blah. Unfavorable effects. Assuming he also has access, to an encrypted credential either by being authenticated and dumping varhome credentials.xml in full, or by recovering it by any other means, might be stored on a Git instance. This file contains encrypted secrets, usually used to connect to other systems. Base64 password contains a specific header, IV AES-CBC ciphertext with padding. All right. Oh, initial admin password. All right, glad I read to the end. Let's try that. So we can't crack the Jennifer user right now. Let's do this. var Jenkins home secrets. var Jenkins home secrets. Initial. File does not exist. Dang it. Okay. Let's see. Master.key. Don't think we looked at this file. Oh. Right. This file contains encrypted secrets usually used to connect to external systems. So, if we look at this, we have SSH user private key. SSH user private key. What am I doing? I got Cyber Chef. So we'll grab everything except the curly bracket. Input recipe from base 64. Binary data. So I think even though this is base 64 encoded, it is encrypted. Dang it. Yeah, so even when this guy converts it from base 64, passes it to XXD. Right, so I still feel like we're on the right track here. Decrypt user. Just looking for a bit of a walkthrough on this particular vulnerability, how people have overcome this Hudson util issue. Alright, it's quite a good right up here. Set up a lab. Beautiful. How to do the exploitation. Wonderful. Alright. How to patch it. Alright. Doesn't address the doesn't address the particular issue we're dealing with. I mean, this guy talks about it, but yeah, so I think this is the path that we're kind of heading down, right? We've got this LFI. We do have an encrypted version of this. We do have a hashed credential here. Oh, do we have access to the Groovy console? No. No unauthenticated access. Right, so this is assuming you've got access to the script console in order to run this function, which then reads the Hudson token or key and do the decryption. So if we had the Jennifer user, I'm assuming we could do this and get that SSH user. So if we go back to Jennifer's password hash, what is a JB crypt? Jenkins. I'm not, now what I'm thinking is I'm not convinced that we need to okay, so credentials.xml. Okay, so credentials.xml is this one, right? Which has the SSH encrypted SSH keys and would store other kind of system level credentials used to, you know, connect to various third parties or whatever it might be. But what we're trying to do is decrypt a user. Now, the user itself, Jennifer in this case, this is a hash. I mean, it's XML tag is password hash. It's not an encrypted password. So I think we crack this the traditional way, which is to say, brute force. We probably want to take this part out. $2.10. Yeah, okay. All right, okay. I should have noticed this earlier, but let's see if Hashcat knows what it is. Yeah, regular old blowfish or bcrypt. M3200 hash user share word list Rocky. Let's let that go. So this is the pathway, I think, is we get look, it's already god damn it. So the user Jennifer is a password hash. Now we've got her login for Jenkins itself. Hopefully that'll give us access to the console. Then we can use this in the script console to decrypt the SSH key. Let's try it. First step is let's record the credentials. Jennifer Jenkins user. Princess. Hey, there we go. And because I just tried to access the script console before, it redirected me to that page. But let's have a poke around now. We're authenticated. No builds. Please update Jenkins. Multiple security vulnerabilities. Yep. If we get stuck, we're going to go and further enumerate all of this. See if there's like a command injection or something that we can do. Something like that. But for now, let's go to script. And the syntax that we want is... Copy that. And we're going to paste that in here. And we'll just get rid of that altogether. Then we are going to grab our two keys that are present in credentials.html. Credentials.xml. Come on. That is definitely an SSH private key. Let's call it private key 1. And we've got another key. Is it the same? AQAAA. Yeah, I think it's the same. Let's do it just in case. All right, diff pk1, pk2, nothing. Okay, rm pk2. So now we're going to ssh Jennifer at IP. First of all, we'll need to chmod 655 pk1. Then we're going to SSH Jennifer at IP using PK1. Yes. Password? Dunno. Princess? No? Oh, what am I doing? Okay. BM PK1. Jennifer. Jennifer. That's right. Root. My goodness, losing my mind. Private key permissions SSH 644. Yeah, of course. What? Wow, there it is. I wonder where we meant to go as Jennifer first. Did we skip a step? Nope. Straight into root. I suppose with the vulnerability we could have... The LFI, we could have grabbed the user flag. Jennifer, home root. Oh, what am I doing? root.txt. Alright, wow. Okay. That was freaking awesome. There we go. Done. Pwned. Yeah, I really enjoyed that. That was a lot of fun. Fairly straightforward path. As in, we quickly identified, we spent a bit of time enumerating Jenkins. It did help that I was a little bit familiar with it, felt somewhat comfortable understanding what Jenkins was and kind of how it works. So that helped a bit, I think. Quickly identified the CVE for LFI. Took a few goes to find an exploit that worked. 2 attempts really. I think that's just the stability of the payload. Wish I had a bit more time to deep dive, really understand how that payload encoding works. Obviously the @ symbol in the payload was important. That's how the path escape was happening. It was unhandled, but yeah, we'll go back and read a bit about that. And then understanding how all of the credentials were stored within the file system. Interestingly, file system, not database. I think that's how Jenkins works. If everything is kind of a flat file, it doesn't need a database to back the configuration and anything else. Yeah, and then just figuring out what was what. A little bit of a rabbit hole there, trying to figure out the confidentiality key. But turns out the user was just a the user was just a hash, a non-encrypted password, ciphertext password, easily cracked. And then once we were able to crack it, we were able to very easily access the interactive script console, which would then let us use that confidentiality key along with the other encryption keys or decryption keys to grab the SSH key that was encrypted and stored within Jenkins. Cool. Really loved it. It's been a lot of fun. If you stuck around to the end of this video, thank you very much. Have a great morning, afternoon, evening, or nighttime, whatever time it is for you. And I'll see you in the next video. Bye-bye.